Hi everybody, welcome to the Laney College Machine Shop. If you're watching this video, then that means that you're at an orientation to possibly take one of our classes. So you're interested in seeing what we have on offer here, so let me go ahead and give you a quick tour. Here's a bird's eye view of the main shop space in all its splendor. There are about 50 machines of various types spread out over 10,000 feet of total shop space. We have a classroom, a computer lab, and a second workshop space. Let's take a closer look and meet all the machines. When you first walk in, you can see the lathe section straight ahead, but let's come back to that. If you turn right, you can see the horizontal bandsaw that we use to cut stock material for projects. And right behind it, you can see the stock rack. We've got steels, stainless steels, aluminum alloys, copper alloys, and plastics of all shapes, sizes, and types. And we've got more material around the shop. A lot of this stuff was donated by our industry partners. To the right is one of our tool rooms. You'll find that we're very well equipped compared not just to other school shops, but other industrial machine shops too, and we're quite proud of that. If you turn left, you can see the vertical bandsaw. It's a very handy tool for removing large amounts of material and rough shaping parts. Moving along, you can see a belt and disc sander, great for rounding edges, and right next to it you can see two of our pedestal grinders. A pedestal grinder is simply a big wheel made of abrasive grit attached to a motor. These are very common tools found in garages and industrial manufacturing facilities alike. One of the first projects in the machine technology program is making cutting tools by hand grinding them on these grinders. Students then use these cutting tools to make their first project on the lathe. Being able to grind custom tools is a valuable skill to have in your back pocket, and it's also a great way to learn about how the metal cutting process works. On the other side of the aisle, you can see our new furnace. One of the advanced projects in the program requires students to heat treat steel to increase its hardness and make it more wear resistant. We discuss metallurgy in general at various points during the program because it's important to understand material properties and how they can be manipulated. Further down the aisle, you can see a hydraulic press we use for installing and removing various components in assemblies. And next to that is what's called a CNC CMM. CMM stands for Coordinate Measuring Machine. It's an automated part inspection machine. It controls a probe to scan a part and then compares the measurement data to a three-dimensional computer model to decide whether or not the part passes inspection. Very slick, and definitely not a tool you'll find in your grandpa's garage. On the other side of the aisle is one of our surface grinders. This is essentially like the pedestal grinders we saw earlier, but instead of holding the part with our hands, we clamp the part to a table which moves back and forth under the grinding wheel. Very useful for cutting hard materials and generating flat surfaces. We've got a lot of other pretty specialized inspection equipment. Optical comparators, microscopes, interferometers. It's not really worth going into any of that at this point, but if you take some classes here, we'll get around to it sooner or later. If you switch back into the next aisle, you can see the other surface grinder against the back of the first one. More grinders of different types, and then the drill presses, another common tool with which you may be familiar. Drill presses are used to make holes in parts by, well, pressing drills into them. There's a project that uses the drill press, this little block with 3 holes. It also has some other features on it that require using a hacksaw and a hand file. It's actually a good little introductory project. Okay, then we come to the lathe section. We have 15 lathes in a few different sizes. We use these tools a lot in the machine shop. I like to explain that the lathe is one of the 2 mother machines, the other one being the milling machine, which we'll see in a moment. In this machine, the part is rotating and the cutting tool is held in a carriage and fed into and out of the part. The tool can be fed in 2 directions, called axes, left and right, and forward and backward. This allows you to create round shapes like cylinders and cones. One of the first projects in the machine technology program is this little shaft that has some cylinders, grooves, and screw threads on it. It's made entirely on the lathe using the tools ground by students on the pedestal grinder, which I think is really impressive. To the left is another tool room. More pedestal grinders, and then the milling machines, 12 of them in total. You could think of the milling machine like a glorified drill press, but I think it's more useful to think of it as the companion to the lathe with exactly the opposite design. In the milling machine, the tool is rotating and the part is clamped to a table and fed into and out of the tool. The part can be moved along 3 axes, left and right, forward and backward, and up and down. This allows you to create flat surfaces. One of the first projects in the machine technology program is this right angle plate, which requires that all the flat surfaces be very perpendicular and parallel to one another. It's trickier than it sounds. Moving along. Okay, now we've come to the CNC, or computer numerically controlled machines. The metal cutting machines we've seen so far have all been manual or conventional machines, meaning that the metal cutting operations are controlled by a human operator turning dials by hand. CNC machines, on the other hand, are like metal cutting robots. They look very similar to their conventional counterparts. For example, this is a lathe. Here's where the rotating part goes. Here's the carriage where the tool goes. This one even has hand wheels for optional manual operation. However, the big difference is that this machine has a control panel where you can upload a simple computer program written in a standardized language called G-code. The machine reads this program line by line and translates it into precise motion of the part and the cutting tool. All the operator has to do is load the part, close the door, hit the green start button, and walk away. CNC machines are an example of manufacturing automation. They've been around really since the 1980s, and they're the norm rather than the exception in production manufacturing facilities today. But there are still jobs which require manual or conventional machining skills, especially in maintenance facilities where large, expensive, and often unique equipment needs to be rebuilt. All machine technology students start on the conventional machines because it's much easier to learn the fundamentals of machining without having to deal with the added complication of advanced computer controls. Students start working with the CNC machines in the second year of the program. Here's another example of a CNC machine, this time a milling machine. Here's where the rotating tool goes, here's the table where the part goes. This is a special device called a rotary head. During a machining operation, a rotary head can rotate parts about an axis in addition to the 3 axes of movement which we usually get on a milling machine. This is called 4-axis machining. This rotary head is currently set up to hold multiple parts so that all of the parts can be machined in a single cycle of the machine. It's a productivity tool. Adjacent from this CNC milling machine is another one with a similar design. And if you go through the door, you can see yet another CNC milling machine. And here's another special device called a tilting rotary table. A tilting rotary table can rotate parts about 2 additional axes during the machining operation. This is called, unsurprisingly, 5-axis machining. It can be used to machine practically any 3-dimensional shape desired. Look up 5-axis CNC machining on YouTube if you want to see some of the amazing things these machines can do. Here's another CNC machine. This one is basically a lathe, but it has a tool turret, and it cannot be run manually. Behind that, you can see another CMM. This one is manually operated, meaning you have to guide the probe with your hands. It's still a great way to inspect and even reverse engineer parts. If you go through the door, you can see the computer lab. We have 20 performance workstation computers, which we use to teach the most common industrial software packages, SolidWorks and Mastercam. SolidWorks is a CAD, or computer-aided design software, which allows you to create three-dimensional models of parts and assemblies. Mastercam is a CAM, or computer-aided manufacturing software, which allows you to take 3D models and generate programs which can be uploaded to CNC machines to manufacture parts. Well, I think that's about it. Oh, yeah, we have a 3D printer. 3D printers make parts, usually out of plastic resin, by pooping out little blobs of melted material and building the part up layer by layer. It's a pretty cool technology, and it has a lot of uses, but honestly, when you have access to the other machines I showed you, and you have the skills to use them effectively, 3D printers just seem like toys in comparison. Anyway.
Well, what do you think?